An entity can be a real world object. So it can be any real world object, it can be animated one or inanimated one, but that can be easily identifiable. We have a same type of attribute here, but the value will going to be differ from one entity to another entity. If I have a collection of an entity, then we are going to call that as a entity set. The attribute value which cannot be further divided, then we are going to call that as a simple attribute. Everybody, a warm welcome to one and all. Welcome back to the chapter 2, session 4 of unit 1 of B.C.A semester 4 and a subject called Database Management Systems, in short DBMS. I am Rohini T.S., Department of Computer Science, Vidhyaashram, First Grade College, Temple of Excellence, MYSURU. So today we are in the second chapter, that is data modeling using entity relationship model. So before getting into today's session, we'll have a quick recap of my previous session. So in our last session, we had discussed regarding the database languages. So here you have to work regarding DML, DDL as well as TCL, and also we have DCL, that is data definition language, data manipulation language, data control language, and also we have transaction control language. So in each languages I have discussed regarding its basic definition along with the commands which comes under the particular type of language, and also we had discussed regarding the Dbms interfaces. How can I talk to a database, on what are the different interface that we have in a DBMS, that is what I have discussed in my previous session. Along with that, we have discussed regarding the different utilities which will going to improve the efficiency of a DBMS, that is regarding what? System utilities. So in our today's session, we'll see about the entity. So we'll see about the entity type, and what you mean by entity sets. Along with that, we'll see about the attributes as well as keys. So before that, it is necessary in order to recall the 3 schema architecture. So you remember we had discussed regarding the 3 schema architecture, right? So in that, how many layers we have? As the name indicates, we have 3 layers. The first layer is what? Upper layer, so which has more abstraction. That is what we are going to call that as an external level. And also we have a second layer or middle layer, that is conceptual layer. And also we have physical or internal layer. So we know the working condition of external, conceptual as well as physical. So we know that in each level or in each level of abstraction, what is the operation it will going to takes place. So in the physical level, it will going to store the raw data, right? So it will going to have a details regarding the records and arrangement of that records and its indexing, everything that we are going to do in this level first, that is physical level, and also in between we have a conceptual level. So it is necessary to understand the working of conceptual model. So in the conceptual, it mainly focuses on the description of a schema, or it will going to define how schema is being generated or what is the schema of this database. Along with that, mainly it will going to specify the constraint, that means set of rules and regulation what I am supposed to follow when I wanted to execute any of the query in my DBMS, like what are the rules and regulation we have to follow. That is what regarding constraint. Along with that, we are going to deal everything in the conceptual schema or in the conceptual layer in the terms of entity and in the terms of attribute as well as in the terms of relationship. So this focuses on an entity, attribute as well as relationship. So it is necessary to understand the concept of conceptual modeling. So with that conceptual modeling, we are going to represent any kind of operation in the terms of ER diagram, that is entity relationship diagram. So that model is called entity relationship modeling. That is what the reason, or this is the prerequisite that we have to understand before getting into what do you mean by entity, what is entity set or what is entity type. So let me get into the today's session, that is with respect to an entity first. So as I told, we have ER diagram that to represent the operations of any of the data model. So it is a diagrammatic representation. We are going to use some of the symbols in order to represent its operation or in order to represent the working of particular attribute or an entity or a relationship. Okay, so then what do you mean by entity here? An entity can be anything. For example, can I consider this as an entity? Yes. How can I say this as an entity? So if an real world object which has a property or which got property will be considered as what? As an entity. So an entity can be any real world. For example, if I consider this pen, what are the attributes it can have or what are the properties it can have? For example, it has a color, it has a size, and also it has a manufacturer, it has a brand, and it has some cost, right? So those are the property. If I consider anything, even if I consider student, so what are the properties of a student? Student has a student ID and student has name, student has date of birth, and they have joined particular course. So everything will be considered as what? Properties. In the same way, an entity is a real world object which got a properties. We are going to call that as an entity. We'll see now. An entity can be a real world object. So it can be any real world object. It can be animated one or inanimated one, but that can be easily identifiable. So for example, if I see any of the car, I can get to know that is a car. How can I get to know that is a car? It has some properties. It has 4 wheels and also it has a brake and also it has what? Steering. So just by looking into its property, we will get to know what it is. That is what we are going to call that as an entity. So an entity is a real world object. It can be anything. So you can consider light, fan, you can consider digital board. Everything has its own properties. Then we are going to call that real world object as an entity. So, and also if you consider the school database, so we have a student, we have a teachers, and also we have classes, course, everything we have. So in each, if I consider the student as an object, or if I consider this student as an entity, so what are the properties it will going to include? Student has an ID, student has a name and date of birth, course and all. So if I consider the teacher, teacher will going to have their employee ID or teacher ID, and also they are going to specify the name as well as their date of birth and what are the subjects they are taking. So if I consider any database, all the databases, within that we have an entity, and each entity will going to has its own properties. And also all these entities have some of the properties or an attribute. What is the another alternative name for this properties? That is attribute. That we are going to discuss in my coming slides here. So that an entity or all the kinds of entity which will going to have some properties or attribute that will going to help them in order to identify. So how can I say? For example, I will just say the properties. Then you tell me what entity it could be, right? So if I say employee ID, employee name, basic salary, HRA, DA. So if I say all those properties, then we can easily assume that this all the properties or its characteristics or its attribute belongs to an entity called an employee. So that is what? It is a real world object which can be identifiable with some of its attribute or a property. So then how we are going to represent this an entity? That too with the help of rectangular box. So as I told, it is a diagram. So we have to use some of the shapes in order to represent each value here. So if I wanted to represent an entity, we are going to use this rectangular box. We'll see the next point, that is with respect to entity type. So now I got to know what is an entity. So now we are talking about the entity type. So I have more than one entity, but all the entity had different attributes or properties. Then we are going to call that as an entity type. So let me consider here. Consider I have a student. Consider I have a student entity, and also I have a employee entity, and also I have what course entity. Okay, so these are my entity. How can I get to know this is an entity? Because I am representing within the rectangular box. So if I say student as an entity, what are the properties it might include? So it will going to have student ID and student name will be there, and their date of birth will be there. All these are what? Attributes. So all these are the attributes. If I consider an employee, so it will going to have a employee ID, and employee will going to have the employee name and their salary. If I consider a course, so course will going to have a course ID and course name. So these are the attributes or properties. Then what you mean by an entity set here? So here, how many entity do I have here? That I include 3 entity. One is student and employee and another one is core. Every entity contains same attribute? No, right? That is what we are going to call that as an entity type. So now we'll see. An entity type describes a set of entities that have the same attribute. So the attribute will be same, but the value needs to be differ from one another. So that set of entity types defines the part of database schema. And also for each of the entity type, there will be multiple entities of that type about which we want to store data in the database. Each of them described by the same collection of attribute. For example, if I consider a student as an entity, at that time it will going to have student ID, student name as well as date of birth. In the same way, I can have multiple entities with the same attribute. That is what an entity type here, but the values of those attribute will be differ from one entity to another entity. So if I consider a student and an employee, so these two are the different entities, but it has same kind of attribute. That means what? Here we have a student ID, here I have an employee ID, here I have a name, here I have an employee name. So those are the same kind of attribute, but the value will going to be differ from one entity to another entity. That is what you have to remember when it comes to the entity type. So next, an entity type serves as a template for a collection of an entity instances, all of which are described by the same collection of attribute. It will going to have a same collection of attribute here, but the value of that attribute will going to be differ from one entity to another entity. So if I consider a student as an entity, then I have student 1, student 2, student 3. Okay. So at that time, each student will going to have a same attribute, but their value will going to be differ from one entity to another entity. Then we are going to call that as an entity type. We have a same type of attribute here, but the value will going to be differ from one entity to another entity. And also an entity type is similar to a class in object oriented programming. So what comparison we are making here? So in the OOP concept or in the OOPS concept, we know about this class. So an entity type is considered as a class, that is a collection of attribute. So class is a collection of objects, but this an entity is a collection of attributes and each of the same kind here. So that an entity instance is similar to a particular object. So whatever the value that I am going to give for an entity, that will be considered as an object here. And we are going to represent an entity in the rectangular box. That is what I have told here. For example, if I wanted to specify student as an entity, it has to be in the rectangular box. So here you can see the example. Before this example, we'll see about the entity set. Okay, so that is what an entity set is, a collection of all the entities of a particular type that exist in a database at some moment in a time. It is a collection of entity. So you just understand, we have an entity and we have entity type and we have entity set. So already we know regarding an entity, that is what real world object. When it comes to the entity type, so here we are going to have a different types of attribute, but the value will going to be differ from one entity to another entity. So if I have a collection of an entity, then we are going to call that as an entity set. For example, I have student entity, I have employee entity, course entity. So if I consider everything together, then it will be an entity set. So it is a collection of the entities of a particular type that exists in a database at some moment in a time. So if I consider this moment of a database, whatever the entities we have, that can be either same kind of entity or different kinds of entities. So if it is a collection of all the entities of a particular type, then we are going to call that as an entity set here. So an entity set is a collection of similar types of entity. So if you consider a student, student is related to course and student is also related to marks table or in marks entity. So it will going to have a similar types of entity, and also entity sets need not to be disjoint. That you have to remember here. An entity set may contain entities with attribute sharing similar value. So let me show you an example here. So here I have two entity, one is employee and another one is company. This is an entity and I have three attributes for my employee entity. So it consists of name, age, as well as we have salary. Then if I consider a company as an entity, then it comprises of name, headquarters and president. So here you can see that in the employee entity, I have instances E1, E2, E3 up to some values, and also here in the company, I have E1, E2 up to some of the instances. Okay. So if you consider the employee 1 and employee 1 detail, everybody will going to have a same kind of values here. That means first I will take the name as well as age along with a salary. So you can see that here an entity set may contain entities with attribute which is sharing a similar values. So if you consider here also they are having some value like 30,000, here 80,000, both are of numeric. They are sharing the similar kind of values. So here also they have name, they also have name, and when it comes to the age also it will be of number. So they are sharing the similar kind of values. Then an entity type describes the schema or intention. So when it will going to have, or when an entity with its attributes have the similar kind of values, then we are going to call that as a schema or intention for a set of entities that shares the same structure. And the collection of entities of a particular entity type is grouped into an entity set, which is also called as the extension of the entity type. That is, extensions is nothing but an entity set. So here if I have a collection of entities, then I am going to call that as an extension or an entity set. So this intention is nothing but entity type that will going to share the same kind of values here. And if it is having collection of an entity, then we are going to call that as an extension, or it will also considered as an entity set. That you have to remember. Entity is a real word, and entity type that specifies the set of entities that have the same attribute, but the value of that attribute will going to be differ from one entity to another entity. When it comes to an entity set, then it will be a collection of the entity of a particular type. So this is the difference between an entity type as well as entity set. So next we'll see about the attributes. So till now I have used a word called properties or a behavior. So if I consider any of the real world object or any of the entity, everything or every entity will going to got its own properties. That properties are called as attribute. So entities are represented by means of their properties. So that will be considered as what? An attribute, and all the attribute will going to have values. So if I say this as an entity, this digital pen as an entity, this has a name, it has a color, and what is the value of this color? It will be black. Okay. So if I say manufacturer, it will going to give some value with respect to its brand, and it has cost. So every attribute will going to have its value. So remember, entity has different attributes, and each attribute will going to have its own properties. Along with that, it has its own values. And also if you consider student as an entity, then what are its attributes? So student will going to have name, class, and it also include the age as an attribute. And for name I am going to give some name, and for class I am going to give some class name, and also for age we will give some values. That is what every attribute has its own values, and entity will going to be described by its attribute, which is properties or characterizing it. I can call properties, characteristics, or we can call that as an attribute here. So this is regarding an attribute. So now we'll see about the types of attribute. What is the first type? That is simple attribute. This is also called as atomic attribute. So simple in the sense what? The attribute value which cannot be further divided. Then we are going to call that as a simple attribute. So if I consider a phone number, can I further divide that phone number? You just imagine, don't say we have what country code as well as 10 number. I'm taking together. So I'm taking all the values together, or else I'm just leaving the country code, then I'm just taking only 10 numbers. So you imagine I'm just taking only 10 numbers of a mobile number. Okay, so can I further divide the 10 numbers into any other values? No, right? Then we are going to call that kind of attribute as a simple attribute. So simple attribute are atomic values, like atomic in the sense which can't be further divided. So which cannot be divided further. As I told, what will be the example? If a student has a phone number which is of 10 numbers or 10 digits, okay, so just imagine we are taking only 10 digits, we are not considering the country code. That is the case, we have only 10 numbers, so I can't further divide that 10 numbers into any other value. Then we are going to call that kind of attributes as a simple attribute. What is the second type of attribute? That is composite attribute. As the name indicates, composite in the sense what? It is a collection, or it can be further divided. So composite attribute are made up of more than one simple attribute. So if I consider the name of a student, can I further divide it into number of values, or can I further divide that name attribute? Yes. So I can have first name, second name, or I can have first name, middle name as well as last name. So that is what composite. It will be a collection of combination or a collection of simple attribute. So if you consider a student complete name may have a first name as well as it includes a middle name as well as the last name. It will be a combination of or collection of simple attribute. So we got to know regarding simple attribute as well as composite attribute. So next we'll see about the derived attributes. So before understanding what you mean by derived attributes, just let me tell you one example. Okay, so every student will going to have date of birth, right? And also based on that we are going to find the age. Then which is possible? So if you say your age, can I find your date of birth? Or if you say your date of birth, can I find your age? Which is possible here? If you say your age, I can't find your date of birth. But if you say your date of birth, then it will be there will be a possibility of finding the age. That is what derived attributes. So here date of birth is the main value. So from this value, I am deriving some values. So I am deriving its value, another value. That is what we are going to call that as a derived attribute. So if you say your address, so if you say your address with from this address, I can get to know what is the distance from my current location to your address. That is what derived attributes. So I am deriving some value from the existing value. So derived attributes are the attributes that do not exist in the physical database, but their values are derived from other attributes which is present in the database. So here I don't have age attribute, but if you have this date of birth, I can find the value of this age, and I don't have the distance attribute here. Instead of that, if you say the address, then I will map with my current address to your address, then I can find the distance. So that it is not physically present in the database, but their values are derived from the attributes which is present in the database. This is with respect to this derived attribute. We'll see the next type of attribute, that is single value attribute. As the name indicates, the attribute which will going to have only one value, then we are going to call that as a single value attribute. At a time, a student can have only one value for a age, right? And if you consider a gender, at a time they can have only one value for a gender. So here single value attribute contains a single value. So if you consider your USN number, or if you consider your PAN card or Aadhaar card, all those are of the unique values. So you are going to have only one value for that. That is what the example for this single value attribute. An attribute which contains a single value will be considered as single value attribute. So next, what is this multi-value attribute? Can a student have more than one phone number? Can have more than one address? Yes, that is what multi-value attribute. An attribute which may contain more than one values. We are talking about the values. So student can add one course at a time, but as per the NAP rules, now we can have more than one course at a time. So you can also take that example as a multi-value attribute, and student ID will be unique. So that is what single value as well as multi-value attribute. So multi-value attribute may contain more than one values. As I told an example, a person can have more than one phone number, as well as they can have more social media ID. All these comes under the multi-value attribute. So this is regarding what? What do you mean by attribute or a property of an entity? Along with that, types of attribute. All these questions will be very, very important for either 7 marks or 8 marks. So we'll see the next type of attribute, that is null values. As the name indicates, null in the sense what? The value, an entity may not have an applicable value for an attribute. At a particular time, we don't have an applicable value. So if you consider an employee, so they just relieved from the working place. So at that time, if I ask what is your designation, or if I ask what is your salary, at that time the value which is not applicable, which has no applicable value for an attribute, that is what we are going to call that as a null value. So that null value can be either unknown or missing. So particular time they are unemployed. So after certain months or days, they will get employment again. That is what? At a particular time the value is unknown or it is missing. That kind of value will be considered as what? Null values. And if it is a complex attribute, then it will be a collection or a combination of composite as well as the multi-valued attribute. So which can be further divided and which will going to be have more than one values for a particular attribute. That is what? Complex attribute. This is regarding attribute concept. We'll see then last concept of the day, that is with respect to key. Are we talking about the house key, car key? No, right? We are talking about a key in a database. So you just imagine I have a table. Okay, consider I have a student table. So in this I have student ID and I have a name, age 1, 2, 3. Okay, consider Raju, Ramu, again Raju, 18, 17, 19. Okay. So now we'll see what you mean by key. Why I am saying this? We have 3 students here. One is Raju and Ramu, another one is Raju. And also that means if I say Raju 2 times, you can understand that we have same name of student in a particular class. So, but their values are different. Then if I wanted to update anything with this student ID Raju 1, that should not affect the content of this student ID 3 and their name is also Raju. That is what the reason we are going to have this key in order to uniquely identify a entry in a table. So that key is an attribute or a collection of attribute that uniquely identifies an entity among the entity set. If I wanted to uniquely identify any of the attributes or a set of attributes in an entity of the entity set, then we are going to have this key. So if you consider this Raju, both will going to have a same name, but their age will be different. Even their ID is also different. So if I am changing any content with respect to this Raju, should not affect the content of this Raju. So that if you consider that, I am going to make this student ID as a unique value. So with the help of this student ID, I can find the particular entity among the entity set. In order to uniquely identify an entity among the different entity set, then we are going to have this key. So if I wanted to make any updation with respect to this Raju, then I will use the student ID called 1 instead of 3. Okay, so you can take the example here. The roll number of a student makes him, her identifiable among the student, because every student will going to have their own ID. So every student will going to have their unique ID. So it will be differ from student to student. So with the help of that key, we can identify an unique entities among the entity set. So this is what the reason. And also we have types of keys in a database. So first is what? Consider the primary key. So as I told, if I make any of the attribute or a column or a property as a primary key, it has to satisfy two constraints. It should not be null. It should not be null, and it must have the unique value. It must include the unique value. So if I consider this one, if I make the student ID as a primary key, at that time I can't leave blank for the student ID, and it should not be repetitive. It must be unique. I can't say take 1 1 1. So it has to be 1 2 3 or any other number which must be unique in nature. So that a primary key is one of the candidate keys chosen by the database designer to uniquely identify the entity set. If I wanted to uniquely identify the entity set, then we are going to use this primary key, and I am going to make any of the column as a primary key. So next we have a super key. So you just imagine we have a student ID, name as well as age. Okay. So student ID is different from one student to another student. But in the case of this Raju, here name is of what? They have same name. So but their ID is different, their age is different. At that time, I am going to take the student ID and age as a properties or an attribute, and I will make these two columns as a super key. So with the help of these two unique values or a different value, I can identify the different entity among my entity set. You can see here a set of attributes, that is one or more attribute that collectively identifies an entity in a entity set. So here I am taking student ID as well as the age in order to identify it uniquely. Then we are going to call that kind of key as a super key. Then what is candidate key? It is a subset of a super key. So a minimal super key is called candidate key. So at a particular time, I am not taking this name as a super key, but I am considering this as a candidate key. So it is a subset of a super key, or else I can consider student ID and name. So this will be one candidate key, and I can also consider this name and age as another collection of attribute, and I can also consider this as a candidate key. And as I told earlier, so an entity set may have more than one candidate key. So this candidate key is what? It's a subset of this super key. So these are the types of key that we have in a DBMS. So it's all about today's session. In my coming session, we'll see about the relationship types, and also we'll see about the relationship sets, then rules and structural constraints along with the cardinality ratio. So that will be the content of my next session. I hope you all understood my today's session. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.